class, we are discussing on registers, isn't it? After this two, I have some more registers, but now I am not discussing about this. First, understand what is this. So now, accumulator A and flag register F. These two are special type of registers. Okay, why? Because if at all you see into this scenario, accumulator is a register which is very close to memory. Okay, now memory means it's a part of the microprocessing unit, isn't it? Right? Don't think that these are not part. They are a part. But memory, whichever is the part of the unit will be accessed very frequently, and they require some intermediate registers. Right? Mostly, whatever we want to give as an output, or maybe we want that, let me tell you one thing. If at all we are having 6 registers, consider the accumulator register is easily accessed. That way I can put it. Easily accessed in the sense the time requirement to access that accumulator register is very limited. Did you understand this statement, or should I explain more? Please try to understand. I am talking about a register hierarchy. Okay, I have 8 registers with me, but in that I am telling that one register is very close to the memory. The access time is very less. Okay, so that register is called accumulator. As the name itself tells, it accumulates. It accumulates what is required immediately and what has to be shown outside and very close to the memory. That's why this is treated as a very unique or very important register. Did you understand about accumulator? Is that okay?
Yes, ma'am.
Yes, right. See, we will get to use this when we write the codes. Okay, so since I understand that this will be like Greek and Latin for you unless you go into the coding. Right. So take that as a preface to the instructions. Once the instructions will start, it will be very easy to understand. So I'm giving the general scenario. Okay, now next one, MPU means microprocessing unit. Okay, flag register. Now what is a flag register? This is also register only. It also it can store 8 bits of data, but it actually gives what is the outcome of the internal manipulations. Now this is very peculiar thing. Let me tell you. The microprocessing unit is supposed to do some logical operations like addition, subtraction, division, multiplication, all these things, isn't it? So when the code is being executed, one should understand that what is happening inside that intermediate also. Please try to understand. You people, when you write the code, what do? You compile it and you wait for the output, isn't it? Then you will have a visual analysis. Then afterwards try to get the output. Then afterwards tell, okay, fine. Oh, my output is this much. Whether it's correct or not, you have some idea about it, right? So since the user has done the coding work and the execution work, then afterwards the output is analyzed. Then you will take that, okay, is it okay or not? For example, if you have a odd sequence generation, this is very simple example I'm telling. That means you write a code. Let us take C only. We will write a code and the odd sequence has been generated. How you will say the output is correct? Yes, it's a general question. All of you be active. How you will say it is an odd sequence? Everyone. Because we know the odd numbers, isn't it? Hello?
Yes, ma'am.
Yes, ma'am.
Correct. So that means if at all 1, 3, 5, 7 and all is coming, that means my code is correct. By mistake 1, 2, 3, 5, 7 will come, then it is the sequence is wrong. How you are going to detect that? Only when the output comes, isn't it? You print it in a file or you see it in a screen, nothing matters, doesn't matter. But 2 comes means immediately it's a wrong one. You will agree?
Yes.
Yes, ma'am.
Yes.
So now, since we are visually analyzing it, we will have an understanding that no, it is not an odd sequence. There is a glitch there. There is a 2 also coming in that. But inside the microprocessing unit, that too at the assembly language level, we are coding, and then afterwards we are expecting an output towards the end of some 100 machine cycles. That means we are waiting for that. So what is happening? That means like we will put the what? I should not be using this word, like lamp in the air and then wait for the result. Then afterwards it will be like whether the lamp will be there or not. Like that it is. No. They also have some interim flags. That is what called it is a flag. Flag means it's an indication. Indication for the logical manipulation going on inside. I use the word manipulation. Logical manipulation is nothing but arithmetical calculations you say, right? Otherwise you can say what some what we say transfers and all, like register transfers and all. So these are all happening inside the unit, right? Exclusively this flag register is used whenever we have arithmetic and logic unit in mode action. That means we are doing some mathematic operation, right? Now okay, so we have 8-bit register, right? And the 8-bit register, I can start with D0 to D7, right? And now I have specified bit showing the importance of the flag, right? Now, to be honest, the number of flags which is available with the 8085 processor. Now, just see, I'm just showing the slideshow. Yes. Yes. Now, just see. So, consider these are all flags. You are able to see?
Yes, ma'am.
Yes. Now, in D0, you have a word called CY. Now, what is CY? CY stands for carry. Okay. Now, if this carry is set, the wording you please follow. If this is set, that means it is equal to 1. It is an indication that a carry is generated. Inside the work going on, right? So whatever manipulation is going on, that is immaterial with the flag register. Flag register is only an indication. Okay, inside some work is going on, a carry is getting generated. Okay. It's an indication that carry is not generated. Did you understand that importance? So that bit D0 is an indication. If that is equal to 1 means it is understood that the internal calculations are generating a flag. Sorry, generating a carry. If that is not set means the internal calculations are not generating any carry. Okay. Did you understand? CY stands for carry. Carry flag. In some books they will say C. Okay. Right. Now go for D2. What is written in D2? D1 and D2. What is written there? P. P stands for parity. Yeah. P stands for parity. Now, parity means depending upon the 8085 series, they are designed for even parity or odd parity. Carefully understand. So, parity bit is an indication to say or distinguish it is an even parity or an odd parity. If this is set, if it is set means set is equal to 1. The word is called set. So if this is set, depending upon the sequence of your 8085 series, so it is a even parity processor or an odd parity processor. Did you understand that? Parity is just a distinguish, what we said, classification between even parity and odd parity. That's all. Depending upon the requirement. So you can say in general, if it is set, it is an even parity. If it is not set, it is odd parity. Simple. Understood? P stands for parity. Now, parity is indication for what? Again, that is very important. When the logical operations are going on, we will be getting lot of results, isn't it? So, if at all we know the even parity and odd parity, it is a clue to the user to understand that, okay, number of ones in that is equal to even number. So, he will have an idea, okay, even number of ones are coming. Otherwise, odd numbers of ones are coming, isn't it? It is a good indication whether the result is true or not. Is that fine? Right.
Yes.
No, yeah. Now, what is the next one? What is the next one?
D4 AC.
Yeah. What is it? AC. AC stands for auxiliary carry. Auxiliary carry means if the manipulations, in the manipulations, if a carry is generated from the third bit to the fourth bit, please try to understand. From the third bit to the fourth bit, then intermediate carry we can say. Then we will say this carry flag will be set. From the third to the fourth. Okay, so for example, I am adding this much. I am adding this. Okay, so now 0, 1, 2, 3. So from here, if a carry is generated, obviously there is a carry getting generated, isn't it? So that means there is an intermediate carry generated for this operation. So immediately this will be set. Now tell me why we require that auxiliary carry. Already we have a carry here. What is this carry then? This carry is at the end of the operation. See here also. What will happen? A carry will be generated or not?
Yes, ma'am.
Yes. This is this extra bit is the last one, D naught. Okay, but this particular one is there here, no? That is AC. This is how we should understand. Okay, this one is for AC. This one is for CAT. Did you understand that? If at all the D naught bit and the D4 bit both are set, that means there is an extra carry generated. Also, there is a carry generated from the third to the fourth. Now tell me a simple question I'm asking, why they use this third to fourth? What is so good about the third bit to the fourth bit? Any clue?
Because they are in the middle.
Yes, little more deeper you go. Okay, before byte, what is that? One nibble, na? Hello.
Yes, ma'am.
Before the introduction of what is byte? Is that correct?
I don't know about nibble.
Oh, you guys don't know about nibble. Oh my God. What? Small KG students knows about this. Computer class, what they did. One byte. You started directly with the byte itself?
Yes, ma'am, it's correct. I think the one nibble is 4 bytes.
Correct, I think what? I'll kill you guys if you come here. One byte is equal to 2 nibbles. Second class, third class people will ask me, will be studying at home. Sir, so hard. I think so. What is that question? One byte is equal to 2 nibbles, right? So now, earlier in the processor, yesterday I was showing the generations also. First they started with 4-bit processor only. Then they extended to 8. So just you can see the hierarchical evolution. So 4-bit manipulation, then they appended another 4-bit. Then it became 8-bit manipulation. Isn't it? So you can understand that they are not in middle. They are actually 4 bits they are considering. Okay. So that means after 4 bits, it is a checkpoint. Right? Whether if a carry is generated means immediately auxiliary carry will be the one who is indication. Okay, don't miss that one. There is a carry, intermediate carry generated. Okay, so that's why auxiliary carry it is assigned here because of this. 4 bits at a time they are manipulating. Is that correct? Is that fine? The justification is fine? Hello?
Yes, ma'am.
Right. Is the justification 2 nibbles is equal to 1 byte? Right. So whenever a 8-bit register, 8 bits are taken, it is considered as 2 nibbles for the microprocessor. So 4 at a time it will read, 4 at a time it will read. Then the operations will be performed on the 8 bits like that. See, I'll tell you, if some people have the habit of doing one column afterwards one column, the additions and all, isn't it? That depends how you are taught, isn't it? Some people take 2 at a time and then do. Some takes 3 at a time and do. That depends upon how you do the addition, isn't it? How it was taught. Yes or not? Similarly, in your microprocessor, it is nibble by nibble. 4 at a time and 4 at a time together. That's why it is called an 8-bit processor. But inside it is taken in 2 cycles, 4 and 4. Okay, so that's what I'm telling the importance of auxiliary carry. Right? Why it is sitting there. Is that fine? Then we will move to the next flag. What is the next flag? In D6, huh? Yeah, D6. What is there written? D6. What is written there? Why you are sleeping here?
Z.
Ah, Z or Z. What is this? What can be Z? Or what can be Z? Hmm? Z stands for 0. Now, 0 is an indication. If this is set, it's an indication the output of the manipulation is 0. Total manipulation. That means the result is going to be 0, 0, 0, 0, 0. Okay. 0 flag is an indication that the output is 0. Right. If this is not set, if it is not set, then the output is some number is going to come. 0 flag is a flag which is indicating that the output of the manipulation operation is whether completely 0 or it is a number. That depends upon the manipulations what we come. Now, for example, if we are doing this addition inside the ALU, what will be the 0 flag condition? It is not 0, no? Just see. If we perform this operation, it is. Then afterwards, it is. Yeah, this is the answer. So, that time, what is the condition of the 0 flag? It is not set. That means this bit will be showing 0. Is that fine? Did you understand? And in this condition, what is the auxiliary flag? Auxiliary flag is generated now. This will be set. And what is the carry flag? Yes, it is set. What is the parity flag thing? 1, 2, 3, 4. Even parity 4. It is set. Or parity means it will reset. Okay, that's all. Did you understand how the conditions are shown for the small operation of addition? Class,
Yes, ma'am.
have some response, please. Some interesting work is going on, isn't it? For an example. And now what is the last one? That's an important one. That will really very, very important. What is the last one? S. What is S stands for? At least
Sign.
wow, yes, it's a sign bit. This is sign bit. Now, sign bit I should not be telling. In your basic electronics, there is a sign. 1 stands for what and 0 stands for what?
1 for negative, I guess.
1 for negative and 0 for positive. Now tell me for this operation what will be the sign flag? See, wait. Sign will be set if it is positive. Sign will be sign will be set if it is negative. Sign will be reset if it is positive. Yes. Now what is the output here for this particular addition? It will be reset or set? Sign will be set. If it is showing 1 means it's a negative number now. If it is showing 0 means it's a positive number. The result is a positive number.
It will be.
Yes, so it is a positive. That's it. This is how we are having this flags. Now you should ask me, madam, after the work going on, why intermediate checks are required? Now here is the answer for that. If this result will be appearing at the output, right? The validation of the output will be done only with comparison with the flag registers. Please try to understand. That means you can understand that in the MPU, microprocessing unit, we have validation checks also. How authenticated it is, just see. Now you can ask me like, this is also called PSW, program status word. Why we will call PSW? The PSW is nothing but the flag register content after an operation is performed. So this 8 bits like this. Now this is all nothing. This is all not filled. No flags for that. Okay. So now these are all empty only. And the program status word after this operation is how much it is? 0, 0, don't care, 1, don't care, 1, don't care, 1. This one, this particular one is called the program status word. Okay, and that particular one will be the validation check before the output is generated. Is that clear? Guys? Hello, class.
Yes, ma'am.
Yes, is that clear?
Yes.
Yes. So this is all about flags, but we will vividly use while programming it. Okay. So don't worry about such type of new entries, but still try to understand that okay, these are going to come in future when we really do the programming. Is that fine?
Yes.
Yes or no?
And will you
Yes.
explain 60
Yes or no?
Z0?
Oh, this one D6.
Yes, ma'am.
D6. Yeah. So D6 is the bit which will tell whether your answer is completely zero. See, for example, if you have answers like this, after some event, not for this event, after some work, okay, you got all these things. That means it is an output which is completely zeros. All 8 bits are zeros. That time it is equal to 1. Otherwise, else all the time it will be reset. Zero flag means it's an indication your result is completely zero. See, if at all I will be doing do the subtraction, what will be the answer? Is that correct? Subtraction of these.
Yes, ma'am.
It is zero. That means what will be the program status? What is the program status word of this operation? Can you just tell everything? Sign flag is what? आगे ना हाँ ठीक है हाँ फाइनेंशियल अकाउंट ले दीजिए नो प्रॉब्लम हाँ ठीक ओके sorry yeah please go ahead what is the program status word for this operation what will be the sign thing for this I have already written now for this you just tell me class sorry listen sign bit is 0
0.
right? Zero flag is set because this one is there. Then auxiliary carry, I don't think it is generated. Then there is a cross. Then parity flag, parity, it is an even parity or not parity? All zeros counted as even parity. Okay? Then, okay. This is the program status. Did you understand now?
Yes, ma'am.
Yeah. So after every operation, this program status word will be an indication to the output. Just prior to the output, this will be red. This is just a validation. If this is clear, we will go to the next topic. Right? Is that fine? Hello?
Yes.
Yes.
Yes, ma'am.
Now, yesterday, I don't know how many of you have opened the books out of curiosity. Did you go through the pin diagram of this? Because yesterday we have already worked out some pin diagrams. What is that? Some 16 lines which are dedicated for the address lines and the data lines, isn't it? 16 are completed. VCC and ground is completed, isn't it? Class, if you don't cooperate, microprocessor, I will stop, I guess. Because this is very important, and if I don't know interaction is there means it's really boring. I can give you the slides and you can also read. Yeah, what do you say? Yesterday, did you people go through that? Any of the microprocessor thing? No, no? This picture, did you see?
Yes,
Anyone?
ma'am.
Anyone? Did you go through the
Yes.
book? Oh, yeah. This pin diagram. So in this one, if at all I have to explain you. So this AD0 from pin 12 to pin 19 and pin 21 to pin 28. It is called the what? Address and data lines, right? So the functional description I will show functional diagram so that you will understand each pin what is its function. Otherwise, how you will understand the microprocessor? Isn't it? So we will start with the yesterday's work only. What are those address lines? What is this? Really?
Voice is breaking.
What? Line?
Yes, ma'am. Voice is lagging.
There are so many glitches going on. Okay, now here this is the functional one. The pin diagram anyway last yesterday's class I am showing. I will now show the both how they really work. Okay, now from this level to this level, I have AD0 to AD7, and this is A8 to A15. There's no internet connection. Hello?
Yes, ma'am.
Yes,
There's no internet connection. What I can hear? It's not. You guys are there or not?
Yes, ma'am.
yes, ma'am.
Now I yeah. Yes, I'm back. Hello.
Yes, ma'am.
Yeah. So 12 to 19 and then what else? 21 to 26.
28.
Yes, 28. Good. So these two, now if you can see the diagram shows this is bidirectional, this is unidirectional, and moreover there's a name also. These are lower order one, which is multiplex. Address lines and data lines both are multiplexed here, whereas here it is unidirectional address lines. Right? Now these two, these all pins are dedicated for the memory, sorry, for the buses, two buses. The name under this is address bus and data bus. Now the bus who actually retrieves the connects these pins are this address bus and data bus. Please try to understand. I am giving the functional descriptions. Okay, if you can see that, right? Is that correct? Is it shown in the diagram? Only that two you tell. Higher order one and this multiplexed address of data bus. Is that correct? Easy? Yes or no?
Yes, ma'am.
Okay. Now,
Yes.
what exactly is just below the address? Multiplex data bus. What is there written?
ALE.
ALE. Now, ALE.
Not audible, ma'am.
Yeah, I didn't speak anything because internet connection gone. Okay. Yes, I joined that. Now I think it should be visible, audible.
Yes, ma'am. Audible.
Yeah, because there is a glitch coming and internet is dropping. Okay, so now if you see this address bus is there, one is a unidirectional and another is a bidirectional. Now let me talk about address bus. Now what is the address bus? The address bus is generally from A to A, sorry, what is that? A0 to A15. That means 15 address lines, 16 address lines are there. But in that two categories are there. One is a lower order and another is a higher order. Isn't it? You will agree? Yes or no?
Yes, ma'am.
Okay. Now what is the higher order one? What is the lower order one? Now I will just tell you two things. First step, it will identify the memory location. And then after the second step, it will transfer the data. Third step is provide timing or synchronization of the signals. Now this is a little complex now. Let me explain it in detail. Okay. Now the address line. I am talking about this address line. Prior to that, I will just explain you what is the job of this MPU, microprocessing unit. First job, second job, third job, fourth job. Okay, 4 jobs I will define. The first job of a microprocessing unit is what? It requires or it reads the data from the memory. Please try to understand. After this job, I will try to tell you what happens. Memory read. Memory read. What does it mean? It tries to read the data from the memory. Are you able to understand that? Reads data from the memory. Is that correct? Then memory write. Yeah.
Ma'am, board is not visible to me.
For others?
Yes, ma'am. Board.
Yes,
For
ma'am, not
others?
visible.
Board is not
Visible, ma'am.
Visible. Shweta?
Visible, ma'am.
No.
Yeah, maybe this is wrong. Internet slow. Maybe follow. Okay. Memory reads.
Yes, ma'am, now.
Yeah. Memory write. Memory read. Memory write. IO read. IO write. Okay, I'll tell you what is it. Now very big things to read. IO write. Now let me go in detail. What is this? A simple microprocessing unit. I am not going to big operations. I am going to very basic operations. What is its job? I can categorize into 4 things. One is the internal operations. Another one is the external operations. The internal operations means inside the unit itself, they will be doing these 2 activities. What is that? It can read from the memory and it can write into the memory. Is that fine? Is that fine or not? Memory read and memory write. So reads data from the memory and writes data into the memory. This one can be categorized as one job. These 2, 1 and 2. Is that fine? Second thing is IO read and IO write. That means we have peripheral devices and from there it will try to read and again try to exhibit output. Now this is actually requires interfacing. This is peripheral activity. After that, it has ALU to do the internal processing, arithmetic and logic operations. Then afterwards, whether it has to be written inside the memory or it has to be thrown out like IO write. Did you understand? Now technically I have it can be categorized into 2. Memory operations means it's an internal. Okay, means external operations. Are you able to classify that? External means simple. From keyboard, you are typing something. How the CPU is understanding? Hello? From
Yes,
ma'am.
keyboard. Yes, from keyboard is an example. Keyboard, you are typing something. How the CPU is understanding that particular words are typed? Keyboard is interfaced and kept now already. Hmm?
Hmm.
Is it yes or not? I will be
Yes, ma'am.
begging you guys to take these two conditions. That means I will read and I you will understand, and where we are writing it on the screen, right? Which is displayed on yes or not. But inside we have these operations already done. Because when a keyboard we will press, automatically the CPU will be taking that whatever pressed into the memory, then afterwards do that work, and then afterwards gets it displayed onto the screen. Is that happening or not? Please try to distinguish between that. IO read and IO write are the two peripheral activities, read and write. That time, because microprocessor was just developed, they are using these words, read and write operations. Read means it is reading from outside device, and write means it is writing onto the outside device. Just like it will read from a keyboard and write onto a display screen. This is what happening. IO read and IO write. Okay. And moreover, please don't visualize a microprocessor as a computer. Okay, microprocessor is a small kit, and to display it, we have small LEDs only. Right. So those are very. I think if I have any 8085 microprocessor in the lab, I'll show you guys how it looks. Okay, so it should be having, we have kits actually, but obsolete, right? But anyway, what about the memory read and memory write? It tries to work out inside the memory, isn't it? Yes or not? You understood what is happening there? Yes. Now, simple steps. So I have primarily these four operations being done by the MPU, right? And to do that operations, I require some communication tools. Right? What is that called communication tools? I require some buses to do these operations. Please try to understand. I started the story already. I have four operations to be done, and the four operations require the communication tools. And who are those tools? These are the tools. Right? Now, these tools I will. What is this address? What do you mean by address? See, prior to that, this buses and communication tools, what hello?
Yes, ma'am.
Yes,
I really cannot help him so much with this also. I don't understand. This stupid college is not even understanding how I what you listen till now. I am telling so many things. Till what level you have understood?
that address versus reverse communication.
Yes, communication tools. So now MPU, in order to perform these four important operations, it has to communicate to memory. It has to communicate to peripheral, isn't it? It's a simple language I'm telling. So what is happening? It will go and ask memory. But who will go and ask memory? We require some tools there. Now let me explain what are those tools. So first thing is it has to that the tool should be capable to identify and move to the memory, get whatever data is there, otherwise write data into there. Otherwise, the tool should be able to communicate with the outside world, which is we will call input output tool, then read the value from there and write the value from there. Isn't it? Write into that or read from that. But at the same time, we require timing factor also. We require synchronization. Synchronization means timing. Time is more important. Timing is more important. or synchronization. Now synchronization, let me explain you, this is very funny. Okay, now I have some buses. Just I am telling a natural scenario, normal scenario. I have some 2 buses, right? One will go from NIT to sector what? Bus stop. Okay, no sector, bus stop. Another one from NIT to railway station. So 2 different things. Is that correct? Hello, you people remember the campus, right?
Yes, ma'am.
Okay. Now, since I have 2 buses, I require all my students, right, from the campus, they are going home. Okay, or otherwise they are coming. That's much better, right? So, how I can keep an idea like synchronous means I want to collect most of the students from both destinations, but there should not be any clash. And moreover, I should use meticulously those 2 buses. How I can plan that? Now, just give an idea. I have 2 buses. They should collect students from what? Your railway station and this one, what? Bus stand. This is a general podium now. Please, anybody can speak. 2 buses to collect students from railway station and bus stand, bus stop. Okay, how I can make a timetable for that? The resources has to be best utilized. Is anybody there in the class to speak? Anyone, speak something.
We will
Check
bring
the
students
common
in regular.
groups.
Tell. Somebody is helping me. Tell. We will bring. Yes, please go ahead. I am giving you open. See, other class won't think anything. You just unmute yourself and speak.
We will bring them at regular intervals.
Yes, please tell. Yeah, go ahead. Go
So
ahead.
we will bring intervals.
Okay. So word came intervals, right? So can I suggest you, like you are telling intervals, na? So within one time period, 1 bus at a time. You are telling intervals means or 2 buses will be utilized at a time. I told resources has to be utilized in a proper manner. We can have a better planning on that, isn't it? They won't clash and resources can be used very efficiently. Don't you think so? If at all we plan properly. Everybody agree? Yes or no?
Yes, ma'am.
That's what. So this is what a planning required when a communication tools also are utilized. Synchronization is required. We cannot send 2 buses together to the railway station. That's a waste, no? During the same time, one can take care of the bus and another can take care bus stand and another one can take care of the railway station. Right? So you can use that in a synchronous manner. See, here the resources I gave very surplus. Two destinations and 2 resources I gave. But if I have only 1 resource and 2 destinations, how you will plan? Did you understand? This is what the program practice is. I have 1 limited resource and I have 2 destinations to cover. That time the planning will be completely different. Don't you think so? Don't you think so? Yes. That is what the planning required for the microprocessing unit to do this job. Right? Why? Because I have resources like this. And who will plan for that? The control unit will plan for that. Right? This is how the hierarchy. Now, control unit plans the timing and the utilization of the resources to perform these operations. Wow, I have done. Just check. The control unit plans properly timing, okay, to utilize these resources to perform these operations. That's all. Isn't it? Now you have an idea what are these for? Clear? Hopefully.
Yes, ma'am.
Yeah. So this is what the job. Now the job is to efficiently use the resources. Now, if at all we are using the resources efficiently, we should understand these tools are capable for what? Now, just like I told, 2 buses are there, right? Normal buses to pick. I should know the capacity of the buses also. I want to pick some 150 students and I have only 100 seats in my bus. What I can do? Over capacity, na? So I should use 2 trips, isn't it? Because 100 capacity is there, I should pick 150 people. I should go 2 times, isn't it? The college bus has to go 2 times, isn't it? Yes or not?
Yes, ma'am.
Yes.
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 Now tell me, two times it has to go means allocation time to reach the destination and back to the back to NIT, and from NIT back to the destination. So 2 time frames are required. 2 consecutive time frames are required, isn't it? But intermediately, see, one set of students has come. I'm giving you a story. Please try to follow. There's a lot of microprocessor in that. One bus will go and pick the first set of students. If at that time the other bus is vacant, no job to be done, it also can be sent there. Who will decide? Control unit will decide. Depending on the availability of the free time or free availability, we can use the resources. That means the second bus also can be utilized for bringing the next set of students. But if the second bus is occupied already, we will not send that to the job. Is that fine? And another one is high priority. So intermediate, what they will do if the director says, okay, no, bus I require it for my personal use. So that time high priority is given to director, isn't it? So that time the students will be waiting in the railway station and director will take the bus. Is that fine? High priority jobs. Hello? You guys are
Yes, ma'am.
understanding? Yeah, this is actually a story I'm telling. Resources, utilization, and how efficiently the jobs we have to perform. So all depends upon the timing. Right. So this is, you have to understand the general colloquial language only is converted to the control unit and the timing thing. Okay. So that's what I told as a novel. Like a novel, you can read the book. Anybody has downloaded that Goenka book? No. Microprocessor book you have downloaded? Let me download and put it in the Netris otherwise. But it is huge. I cannot. Okay, I can send the Google Drive, I think, isn't it?
Yes,
Yes.
ma'am.
Yes, ma'am.
Yeah. So let me get it down. So when you read that book also, no, you feel that like really it is happening. Like what the general example I have taken, that only will be considered there also. Just like that, okay, I require to move there, I require to get here, I require to data transfer, I want timing signals, like that only the explanation will go. So this is how we have to, now today at least you are familiar what is this operations and who is in charge of that and with what resources we will do this one. That's it to perform this. Right now, I will go to the first one resource and explain what is all about this. Then afterwards, the second resource. Isn't it? So every time one resource we will try to check out and then understand that. See, 1, 2, 3 classes, maybe this is the second class only. So few more classes, we will understand the meanings of that. Then afterwards directly to the programming. I require only 2 more classes to complete the description of that. Then afterwards directly programming, you will understand everything. Got it? So now if at all I go to the first one, address bus. What is an address bus? The address bus is a unidirectional bus. Now you can question me, some part of the address is bidirectional, some is unidirectional, but I am mentioning that address is unidirectional. What do you mean by that?
Data are bidirectional, address is unidirectional.
Yes. So address is always unidirectional. What does it do? The address bus performs the function to identify a peripheral or a memory location. First step. Okay, to do this one, first identification is required. And who will do this job? Address bus will do the job under the control unit workout. Right? Address bus is to, first step is to identify. What do you mean by identify? It identifies the peripheral or the memory location. Now see, I have 2 activities to do. This is memory based, internal based, this is external based. So whether it is external or memory based, it has to identify. If it is memory, it has to identify the memory location. If it is external, it has to identify which peripheral is working there. So address bus thing is it has to identify the location, otherwise it has to identify the what? It has to identify the peripheral thing. Now the address line, okay, now the address line are how many? Total number is 16, isn't it? Yes or not? Hello?
Yes.
60. Okay, now let me explain what is an address. Now, if at all you see, right, name, street name, now what happened? You have thrown me out or what happened?
Ma'am, voice broke in the middle.
Voice has broken. I am also broken only. All the students are also leaving. God forbid. Okay. Did you see what I was explaining here at least? Something I have written. That time I am not there, na, in the meeting?
No, ma'am.
No. Okay. So, address. If at all you people want to identify me in Rourkela, right? I require name, my house number, street name, city name, district, its pin code, state and country. Is this a normal address or not? Yes? Postal address.
Yes.
I'm talking about a postal address.
Yes,
Right?
ma'am.
Okay. Now, postal address is having a format. Isn't it? That's why the postman will come, deliver the his job and deliver the letter and go. Isn't it? How he will identify? You have the system now. You have the system how the postal office will work. We will have different postmen, and each postman is dedicated to one area, and that fellow will know every areas. Is that correct? Every houses in that area. Is that correct?
Yes, ma'am.
Exactly that only this address bus will form. Exactly that thing. That means the address bus will already have a hint of which part of the memory it has to go, and from there the house numbers will be there. No, that will be the locations. Please try to understand. Exactly like a postman. What happens if this is a big stack of memory locations? It doesn't mean that address bus will go to the whole memory and check. It knows or it have a clue to which part of the memory locations it has to go, and from there it can get the house numbers from that. Simple. See, NIT campus is there. Is just like your hostel also. See, which hostel if it is gone means, which wing means, automatically they can understand, isn't it? It's like the same thing. Did you understand?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, okay. Now tell me. Now, if at all in your room numbers starts might be from, what is your room numbers, like a number of digits? Hello?
3 digits.
4.
4 digits. Four digits. Right. So this will be common, and only maybe this will be very. Can I do that? Like that till 1010. See, if I know this 10 is common, the last two are varying, isn't it? Can I take that way? Even the address bus also can take the locations. That means the 10 is common, the series is common, only this is varied. It also searches like that. It doesn't mean that it will enter into every wing and check. 10 is common. This is only varied. Please try to understand how much time it will save. Are you able to identify how the memory is getting checked out? Is that correct?
Yes, ma'am.
Yeah. So this is how the pattern works. Then its job, address bus has to identify the identification criteria also. Now if you see how much time saving it is, because 10 is common. So all the requirement of 10 is separated, and then the location will be very easily checked out. Is that correct? Right? Now you tell me, in the 8-bit processor, what is the size of the memory? 64K, isn't it? Yesterday we have done, na? 64 kilobytes?
Yes.
Yeah. So that will be the memory. So what will be the memory allocation? I'll tell you. Now it's like financial distribution. Total is 64K memory. Right. I can allocate 10K for a specific action. That means I'll keep all the registers into that 10K. Total is 64K only. KB, that too, kilobytes. Okay. Now I will take something around 12K for what? For some, this is for what is the registers we can keep, and this is for counters we can use, right? For the counters to be utilized and all, or for memory actions and all, we can use our peripheral actions, peripheral interfacing. This memory can be utilized. Okay, I'm talking about this is actually the ROM and the RAM together for the microprocessing unit. ROM plus RAM. This is the total memory it's available. That's all. We have to keep the instruction also one part of that, and apart from that I will utilize the portion left after that for the normal things. Okay, you can understand like how in small memory space they are using the task. Okay, so this is efficiently allocation of the memory, and in that itself this whole action is done. You are able to understand that at least? Yes or no?
Yes, ma'am.
Yes. Now, if at all you can think about it, what will happen here? I'm just trying to show one simple diagram. Memory interface. Yeah, that's the second. If at all you see that, it will be easy for you to understand. Two seconds. I'm just showing that in the direct picture itself. Think. Okay then, leave it. Another one is there. Okay, forget it. Right. I will draw that. Okay, so these are the lines from. Okay, I think tomorrow tomorrow or day after tomorrow I will show you. I think Friday you don't have my class, but you are free, isn't it? Yes or not?
Ma'am, at
Hello?
what time, ma'am?
Friday, ma. Friday, I'll just let you know, Sweta. Okay, I forgot that PPT to get.
Okay, ma'am.
Right. So that I can just show you how exactly the memory management will be done. I just want to show how the data will be taken, and from here how it will be conveyed here, and how this will be conveyed to this. So if at all you can see that bus management, it is very easy. So this is the address bus thing, and this is the data bus. From here to here. From here to here, and from there to there. So this is the memory. And this is the data given. If you can see your Goenka book also, that also will be there. So from the MPU unit, that means microprocessing unit, how internally it is working. We have exactly the internal one I have portrayed outside. Inside the action is that we are showing it as a pictorial representation to see that how the functional is worked on. Functionality is coming inside course. Is that fine? So Friday class definitely at least 1.5 hours I will take, so that little bit is completed. Is that fine, ma'am? I'll let you know.
Oh,
Thank you.
okay, ma'am.
Thank you. Oh, now you can leave for lunch.